So here's this video about why you should switch to solar power. For this example, we will be using Oklahoma, as it's my home state, and this will only apply to the country of the United States of America, as this is the country I live. Some of the examples in this presentation will apply if you are outside of Oklahoma and outside of the United States of America, but you should look up for your exact local area, as this is the places that this research most applies. In Oklahoma, we have 389 hours of daylight per year. Alaska has some of the worst, and Arizona has some of the best. We also have 5.5 peak daylight hours. Being part of the Sun Belt gives us a extreme advantage in solar production. However, there is a key difference compared to us than most of the Sun Belt states. We have a net metering law, which net metering law basically means that if you produce 1,000 kilowatts of solar and you use 1,000 kilowatts, the utility company is forced to refund you your 1,000 kilowatt consumption. So it nets out your bill to zero. Well, for energy, you still charge a fixed 20% fee for using the grid, which that is still, some people would scoff at that, but 20% is way cheaper than the cost of a battery. So that cuts the total cost of solar in Oklahoma by nearly 30 to 50%. Because batteries are a massive part of solar system consumption. So instead of a battery, just use a grid. 33 out of the 50 states apply to this, though you should look at your local examples. And lack of demand pricing. Demand pricing has an additional advantage, because if you're on a fixed bill, that makes these credits work better, and it's easier to apply, because that example only works if it's fixed billing. If you will have a demand pricing, it can't easily refund. So if you have fixed billing, it does work. Oklahoma has some of the most successful demand pricing systems. You can see that we have high participation, but also most of our energy companies allow for fixed billing, which, if you are doing solar, you should do fixed billing. This has an extra additional advantage towards lack of battery, because another thing batteries can do is basically pay for themselves by using demand pricing to even out your billing. So instead, you could buy energy when it's cheap and use it when it's expensive, so it can save your energy. If you are in a fixed price, there's no reason to do that. If you're in Louisiana or Mississippi, for example, there's no reason for you to have it. It's just not bearable. And we can go back here. These have, Mississippi and Louisiana don't have the exact same thing as Oklahoma, but they still have something, and I would look into it if you were living there. Now, for this exact example, we will be using this person. This person lives in Oklahoma, which their energy average is 12 cents per kilowatt, and they use 1,977 kilowatts per month. We're going to be using this solar system as it's 2,474.23, which felt like a reasonable amount. We'll get onto economy of scale, but that's an important thing to keep in mind. The production of this solar system is 4,309 kilowatts per year. Here's the website for doing this. I will put it in the description if you want to use it. The tilt is important. The tilt has to be the latitude you're at. So Oklahoma's at 34.79, I believe. So you round that up to 35. and that gives you the perfect tilt for your solar panel. And it does make a difference of, I think it's about 100 kilowatts per 5 degrees. So it is important to be at the right tilt. Now, we now have these numbers. Your production is 336.58 kilowatts per month. We have the cost of the system. We have the energy consumption. You do 1,977. The percentage saved is 17.02. The cost of consumption per month is 237.24. So the math works out that you save 484.54 annually for this solar system. So the return on investment is 5 years and 3 months to break even, with an expected annual return of 19.11 over 9 years, which a solar system often lasts for 20. However, let's go back here, the inverter and no, I think it's just the inverter. The inverter, you need the reverter and the cables. That's what I was remembering. The inverter and the cables need to be replaced every 7 years, which does add a cost, but you will by far make your money back by that point. Also something important is the economy of scale. I mentioned that would come back. Solar systems have an extreme economy of scale, which means that as the system gets larger, the cost per watt massively falls off. Residential systems cost way more than a corporation doing it. The bigger it gets, the way cheaper it gets per watt. It often decreases at a 10 to 20% over every 10 jump. So you can expect that a system making 25.6 kilowatts would be 20% less than what 10 times this is. So it would be 20% less than 24,000. And if you want to know, for this example, to fully cover out this, it would be 14,500. But that is not counting the economy of scale. So, here's the video. Thank you for watching. Leave a comment on any question you have, and I will reply as quick as possible. Please subscribe and like. I enjoyed making this presentation for you all.